Everyone, in this video I would like to explain about GATE 2020 electrical engineering EMF electromagnetic field theory question. The question is, let AR, A5, AZ be the unit vectors along r comma phi comma z directions respectively in the cylindrical coordinate system. For the electric flux density, this is the value coulombs per meter. The total electric flux in coulombs emanating from the volume enclosed by a solid cylinder of radius 3 meters and height 5 meters oriented along the z axis with its base at the origin. So that means if we clearly observe this problem, is given the information about the electric flux density. Electric flux density, and that is 15 AR bar plus 2R A5 bar minus 3RZ AZ bar coulombs per meter square. This is the electric flux density vector he is given and is asked to calculate the electric flux in coulombs. We want electric flux psi. That means we came to know that the relation between the electric flux density and electric flux, it is from the Gauss law. From the Gauss statement, the total electric flux passing through any regular surface area is equals to the charge enclosed by that, and mathematically we can write Gauss law is equal to psi, which is also equals to q equals to surface integration of d bar dot ds bar. Okay. Now see, if you want electric flux psi from d bar, we can directly substitute in this formula in this integrand, and if we calculate the integrand, then we will get the psi. Or we have one more way of calculating the electric flux by using this expression, by using this d bar. It will be like this. We know the point form of Gauss law. This is the integral form of Gauss. From the point form of Gauss, that is del dot d bar is equal to rho v, that is the volume charge density. So by using this point form of Gauss law, we will first calculate the volume charge density rho v in cylindrical coordinate system CCS. Okay, after calculating rho v, will evaluate the flux or charge. Okay, the relation between rho v and phi is q equals to volume integration of rho v into dv, qr, which is also equals to phi from the Gauss. So that means we need to evaluate the rho v volume charge density first by using this divergence of electric flux density. Then after getting the value of rho v, substitute this formula to evaluate the flux. Now we will start calculating the volume charge density first in the cylindrical coordinate system. Right. Yes, volume charge density rho v is equals to divergence of electric flux density. So we know that the divergence of electric flux density in the cylindrical coordinate system is 1 by rho into dou by dou r of, not rho, r rho, r into dr component, r component plus by r dou by dou phi of is d phi. Next plus dou by dou z of dz. This was the divergence of electric flux density in the cylindrical coordinate system. Okay, the given d bar is equals to, it is 15 AR bar plus 2R A5 bar plus, or not, it is minus 3 r z, 3 r z into a z bar. So now if we compare this equation d bar with the dr a r bar plus d phi a phi bar plus dz a z bar, the values of dr will be 15, d phi is 2r and dz is this one minus 3r dz. So now substituting all the values in the row v, that is 1 by r dou by dou r of r into what is dr from here, that is 15 plus 1 by r dou by dou phi of what is phi component, that is 2r plus what is dz dou by dou z of dz is what here, this is minus 3r into z. Okay. So now do the differentiation here. So here if you see here, rho v is equals to 1 by r, differentiation of r with respect to r, it is 1. So there is a constant here, that is 15 into 1. Similarly plus 1 by r into dou by dou phi of 2r, this is not in the function of phi, so it is treated as constant of differentiation is 0, entire term is equal to 0. Now minus dou by dou z of 3r into z, so 3r is the constant and z is a variable, differentiation of z with respect to z is 1, so here we'll have only 3r. Okay, so now our rho v is equals to 15 by r minus 3r. So if we do the LCM here, that is r and it is 15 minus 3r square. Now our rho v is 15 minus 3r square by, so we got rho v now. So now by using this rho v, calculate the electric flux. Electric flux is equals to, or charge enclosed by the closed surface is equals to volume integration of or triple integration of rho v into dv. In cylindrical coordinate system, we know that the differential volume is r into dr into d phi dz. Rho v is just now we got it. Now substitute it in this formula and calculate the value for psi electric flux, that is one integration is with respect to r, one integration is with respect to phi, one integration is with respect to z. So now if we consider this is integration with respect to r, the r limits in the problem is given, see here, radius of the cylinder is 3 meters, height is 5 meters, that means radius is r is equal to 3, z is equal to 5, and phi we know anyway, phi is limits, the limits are phi from 0 to 2 phi, is 0 to 3, and phi limits are from 0 to 2 phi, and z limits are from z is equal to 0 to phi, and rho v is 15 minus 3r square by r into r dr d phi dz. So here r gets cancelled and evaluated the integrand with respect to r, since the integrand is in the components of r only. So and whereas we have integration with respect to phi and integration with respect to z, so there are no phi and z constants in the integrand, so that is the reason why we do the integration with respect to r first, that is 15 into, there is no term here, 1 with respect to r, so it is treated as r. R limits are from 0 to 3 minus 3 into integration of r square, so it is r cube by 3, limits are from 0 to 3 gets cancelled here, and this was the with respect to r, and see here there is a one more integration, that is with respect to phi, as there is no phi terms in this component, that is the reason why we will have a 1, and the integration of 1 with respect to phi is phi